Recording in progress.
Now, when we integrate, let's say 1 over x, the normal rule of integration does not work. The reason it does not work is because if I move this thing up, that becomes x to the minus 1. And then if you add plus 1, that becomes a 0 over 0, which is impossible. So we cannot do that the other way. So what you need to know is there is a rule. We need to remember the rule. The rule is integration of 1 over x is actually a ln of x, obviously plus a constant of integration. So we need to know that rule, ln x plus c. Let's say if I need to integrate x 5 plus 1 over x plus 1 over square root x dx. I need to integrate them separately, the first, the second, and the third term. Okay, this one I can also write 1 over x can be also written as, before I integrate, can also be written as 1 over x to the power half. Half is 0.5. Yeah, I can do that one. Or I can, this 0.5 can be moved up, and I can just write this thing as x to the power of minus 0.5. So that can be x to the power of minus 0.5. And then I go 1 over x plus x to the 5. Okay. Now, if I want to integrate now these bits, I need to integrate them separate. So when I integrate the x5, I can write it down as x5 dx. Let me put a number 7 here, just in case, So let's say there was 7 over 1 over x. So I can just move the 7 out. 7 times 1 over x. Yeah, let's do that way, because then we know how to do that. Plus the 7 and integral of 1 over x dx plus integral of x 0.5 and negative 0.5 dx. Now let's integrate this thing. If I try to integrate that one, that will become a x6 over 6. That one will become the 7 ln of the x. That becomes positive. That becomes x minus 0.5 plus 1 divided by minus 0.5 plus 1. So that's how we will do that bit. Now, let's simplify one more step. The x6 over 6 as it is, plus 7 ln x as it is. Now that one will become plus x to the power 0.5 over 0.5. I can simplify that one. x6 over 6 plus 7 ln x, 0.5 at the bottom becomes a 2 at the top. Yeah. Okay. And the most important thing is the constant of integration. Make sure you add that one in the end, constant of integration. That's the important one. Let's say if I got equation y equals to sine x, and I want to find the area under the curve. Now, the limits, I want to find the area under the curve from 0 to 360. But if I find that one from 0 to 360, the answer is going to be 0. The reason is because this one is a positive area, and the other one is a negative area. Well, obviously, you can't have 0 area under the curve. To do that one, what we do is we actually integrate. We actually integrate the sign. So let's integrate the sign. integrate the sine x, and then I apply the limit. So first I find the area from 0 to 180. So 0, 180. Now I'm doing in degrees. Now sine integral is a minus cos x, and then there is limit 0 to 180. So I need to do that one first. So I need to do is minus cos 180 minus, actually I can take the minus out straight away. I can just take the minus out. The minus will become positive anyway because there's some odd sign. So minus cos 180, then I'm going to do minus cos 0. What's the value of the cos 180 in your calculator, please?
-1.
And cos 0 is still 1?
1.
Cos 0 is 1. Okay. Okay. Now you can put 0, 180. You can also put, like, make sure you calculate in the right mode, or you can do 0 pi is 180, 2 pi is 360. So you can do that one. So that becomes a cos minus cos 180 minus another cos 0. So if you put that in calculator, cos 180 is actually -1, and cos, so that becomes a -1, and the other one is going to be cos 0 is a 1. So actually this is 1 as well. Cos 180, can you do cos 180 just in your calculator, or cos pi? Cos pi is much better.
0.99849.
I don't know what's wrong with your calculator.
Yes, for me. 0.99. Yeah, I've got the same. Oh, it's 99849. I'll put 99849.
So we got this area as 2. Now we need to find this area, the bottom area. Now we do the same. We don't have to, because we already integrated this thing. The answer is that. So now I'm going to do minus cos x, but this time the limit is from 180 to 360. So when you do this one, this is how it will become. You will have, this minus is already here, minus cos, instead of upper limit, just put on upper limit 360, then minus, then another minus, cos lower limit 180. Now cos 360. So if I do cos 360, it give me answer as 1. So that will be -1. And then minus becomes positive. And if I do cos 180, it's give me answer -1. So positive -1 is another -1. So that's going to give you -2. -2 mean the area is under the curve. +2 mean the area is on the top of the curve. So the total area is 2. We need to get rid of this minus, yeah? So +2. So that is going to be the total area under the curve is 4. Because we cannot integrate sine square x. We cannot integrate like sine A, sine B straight away. So to do that one, we use these identities. Sine A, sine B equals -½ cos A plus B minus cos A minus B. Where we got this formula from? We got this formula from actually expanding these formulas. If I do one and the other, you can have a look. This is how it works. Cos A plus B has a formula. It is cos A cos B minus sine A sine B. That was a formula. Now I got the cos A minus B. Cos A minus B. It has a formula. Cos A cos B plus a sine A sine B. And let me just subtract these ones. If I subtract these ones, cos A plus B minus that one. So on this side, it will become cos A plus B minus this thing, cos A minus B. But on the other side, if I subtract that one, that cancel out, and that becomes a minus 2 sine A plus B. If I move the minus 2 on the other side, it becomes a minus half, and then cos A plus B minus cos A minus B equals sine A plus B. So we got that formula here. You can either use straightaway formula, and if you don't remember the formula, you can actually derive the formula.
Because
No, I wasn't recording. Okay, first we convert this bit into cos 3x cos 2x by using this formula into half cos A plus B. So I got the cos 3x plus 2x plus cos 3x minus 2x. And this is the big integral sign. This one, the blue one here, and that one. Obviously, I cannot integrate the positive half, so positive half comes out, and I integrate them separately and separately. Let me just put that in red. So that is, and this is, and then when I integrate the cos 5x, it becomes a sine 5x over 5. Cos x is sine x. Now I didn't put the c, we can put in the end. Half is outside, you can multiply that inside, sine 5x over 10. Now remember, this 2 doesn't multiply with the top 5, it's only multiply with the bottom one. And there is an invisible 1. So this 2 multiply with 1, give you that one. And that's how we do this part. Okay, let's say I want to integrate sine 4x and sine, let's say 5x. No, not 5x. Let's do 10x. 10x. Yeah. Okay. The easy way to write it down is, if the question is like that, the easy way to write it down is write the bigger one first. Rather writing that one, you can swap them, you know. So write 10x maybe here, because that will make your life a lot easy. And that's 4. The reason is because it's easy to do 10 minus 4 than 4 minus 10. And then you need to work the negative side out as well. Okay, now I need to have a look at which is that one. This is, they're both signs, so it's going to go with that formula, the first one. So that will become minus half, I'm not integrating yet, cos A plus B, so cos 10 plus 10x plus a 4x minus cos 10x minus 4x. Okay, I haven't put the integral sign, so let me put the integral sign. So let's integrate here and here. I just put the half out because constant, we just put it out. Okay, now let's have a look at this bit. Now let's try to integrate this bit. The half is already out. And I need to, and this integral is still there, but this thing becomes a cos 14x minus cos 6x. And let's put the integral sign. Now, the next bit, minus half is there, I need to integrate the cos 14x dx minus integrate cos 6x dx. So I just put the integral sign in the middle. That will give me minus half is still there. Cos 14x becomes a sine 14x over 14. Cos 6x becomes a sine 6x over 6. If you want, you can multiply the negative half inside, and you can simplify the answer a bit more. So that becomes a negative over 28. Negative negative becomes a positive sine 6x over 12. Okay, do not forget this C, a positive C, concept of integration. Cos 2 omega t and sine omega t dx, it can be anything. Now this is cos and sine, so it goes with that formula, but the sine is first, the cos is second, doesn't matter. So you can actually swap the places if you want. Yeah, it doesn't matter. Now, to do this one, what we're going to do is we are going to use this formula. We're going to use this formula. But before I do that, I need to actually write in this form because that will make your life a lot easy. So let's do that. Becomes the sine omega t dot cos 2 omega t dx. Now that's the formula. So let's write it down. It's going to be half here. The A is omega t and the B is 3 omega t. Yeah. Okay. So I got half here outside. I haven't started integrating yet. I'm just like writing the formula. It's sine A plus t. So I got sine A plus t, omega t plus a 2t, and then a positive, and then a sine A minus b, omega t minus 2 omega t. I haven't started integrating yet. I need to simplify that one first. So the half is still outside. Omega t plus 2 omega t is 3 omega t. And this one becomes a sine minus omega t. Okay, one thing you need to remember about the sine minus omega t. Sine minus omega t, if you go calculated, if you put sine minus omega t, or let's say sine of minus theta is same as minus sine theta, which means this minus can come out here. So this minus will come out here. And that thing will become a sine 3 omega t minus sine omega t. And half is still here. Now, let's integrate. So there should be an integration here, integration here, integration here, integration here, integration here, and integration here. Now we're going to integrate. So I can integrate the sine 3 omega t, and I can integrate the sine omega t as well. So half is still outside. So this half already outside. Now if I integrate the sine omega t, I know the integral of the sine omega t is a cos omega, sorry, not cos omega t, cos 3 omega t. Omega. Oh, okay. I made one tiny mistake. If you read the question, there is no x there. The variable that's involved, is the t. So we are we are doing that one with respect to t, not with respect to x. So that's going to be t. That's going to be dt. That's going to be dt. Which means that's the one variable we are integrating. So sine 3 omega t, okay, divided by, okay. Now 3 is constant and omega is constant, divided by 3 omega. Remember that one, because t is the x that disappear, because we're differentiating with respect to t. Now, differential of the sine is, I missed the sign here, I will write it down. Actually, let's write it down here. Differential, sorry, not differential. Integral of the sine is a minus cos. And that one become a minus cos. So this minus is already here. Minus and minus become a positive. And this thing will become a cos omega t, 1 omega t actually, over omega. Now you can write like that, or you can multiply the half inside. If you multiply the half inside, it will be, let me write it down. It's going to be a minus cos 3 omega t over 3 times 2 is 6 omega. And that will become a plus cos omega t over 2 omega. And there is a constant c. So this is how we integrate that bit. Now we cannot integrate the cos square x straight away. To do that one, we need to break it down. To break it down, we can actually do cos x dot cos x and integral operator, and then we actually just go with this bit, the cos a cos b. So we can do that one, but obviously both are xx, so we can actually work this one out. That will be half. I'm not integrating yet. Cos a plus b, so that becomes a cos x plus x plus cos x minus x. Okay, the first one will become cos 2x, and the other one will become cos 0. What is cos 0? Cos 0 is a 1. Okay, now I need to integrate. Okay, obviously you need to put the integration sign, but I'm just putting the integration sign here. Okay, half is still out. Integral of cos x is actually a sine 2x. Cos 2x is sine 2x divided by a 2. Integral of 1 is x. Why it's an x? Because we differentiate integrating with respect to an x, so that's x. Now, do not forget the positive c. If you want, you can multiply the 2 inside, and you can simplify it further. But that's the kind of answer for cos square x. If it was sine square x, you could have used the top formula, sine x, and then you can integrate that.